Abstraction. Abstraction is the process of reducing complexity by focusing on the main idea. By hiding details irrelevant to the question at hand and bringing together related and useful details, abstraction reduces complexity and allows one to focus on the idea. Abstraction is a big idea in computer science. It means removing unnecessary details and focusing only on what matters. This helps make problems simpler, easier to manage, and easier to solve. Driving a car is an example of abstraction. When you're driving, you're only worried about the steering wheel, pressing the gas pedal, the brake pedal, etc. You don't have to worry about how the engine works, how the fuel is being injected, how the brakes are connected. You're focusing on driving, not the technical details that you don't need to know. That's abstraction. Cell phone apps are also a form of abstraction. Let's consider your calendar app. The important details are all you have to worry about: date, time, event name. You don't have to worry about how the data is being stored in your phone, how the time zone is used to calculate the times, etc. You abstract away the technical storage and information so that you can just focus on managing the events. Data abstraction provides a separation between the abstract properties of a data type and the concrete details of its representation. Data abstraction manages complexity by giving data a name without referencing the specific details of the representation. It hides the details of how data is stored or implemented and only exposes what's necessary for using it. Data can take the form of a single variable or a collection of data, such as in a class or a set of data. In programming, you can work with objects and data types without worrying about how they're built internally. Data abstraction is important because it simplifies code. You don't need to know all of the details about something in order to use it. It improves readability. You're working with meaningful names and structures, not binary code, for example. It also supports reusability. You can reuse code without rewriting how it works. You can store temperature in your code as a double. For example, double temp in Celsius equals 36.6. You don't need to know how a double is implemented. You just know that when a temperature is inputted, it will be stored correctly. At the abstract level, we're just talking about a temperature, a real-world concept, like body temperature or room temperature. But at the concrete level, the computer has to store that idea as something it can work with, and in this case, that would be a double value. Consider the code below, which adds items to a shopping list. Here we create our new shopping list, then we add eggs and add milk. You're abstracting away the data structure and just focusing on what you want to do. You don't need to know how items are stored or how the add method works. You just get to use it.